efficiency of the excavator. Todd?
Thank you for the introduction, Jason. As Jason mentioned, I'm the field application engineer for Hemisphere in North America. Today, I will be running you through a brief overview of grade metrics. I will start with how the machine operator would use the system to grade with an excavator. Currently, we have 3 different ways the operator can set the machine up to get cut or fill. The first would be creating a job inside of grade metrics. This option would be used if the project had been designed by an engineer and the job has a set of blueprints or plans. These plans will be based off a known horizontal and vertical grid that the machine will have to match. I have an example of a job loaded and shown here. Notice all of the grade breaks shown on the side of the road in the cross-section view. This is showing you an image of the excavator bucket as you are looking at it from the cab. The red is the surface that we are wanting to cut or fill to. If I zoom on the plan view and start to approach the curb, you will notice that both the plan and cross-section views change to reflect the location of the machine. Along with the cross-section view, the operator can use the light bar located here on the left side of the screen to adjust the bucket to maintain grade. Watch when I go past the back of curb. The light bar will now indicate that I have a foot plus of fill. Now, when I go back into the road prism, it returns to grade. Grade metrics has additional views that will help the operator maintain grade. These can be found by using the icon in the upper right-hand corner. Some of my favorites to use are plan, section, and profile. If cutting or filling a slope, the profile image here in the lower right will show the operator where grade is. Plan and section will add a large cut fill area that is easy to see in your peripheral vision, and will also display both the current crossfall of the bucket in a percent value and also show the crossfall of the design surface directly underneath the bucket. The profile and section view is useful when we create our own designs, and you don't have to worry about any of these kind of grade breaks. For now, I'll just stay on plan, section, and profile. If the operator would want additional information like elevation or design elevation, it can be found in the information summary. Simply tap on the icon here to open. It will display a multitude of information that can be customized to show more or less data. It is important to note that the information summary is obtaining that information from a specific part of the machine, shown by this green triangle in the cross-section view. It is now set to bucket left. If we wanted to know what elevation we're at on the right side, you must have to click and hold on the bucket to change it. Now, the information summary data will be referred from the right side of the bucket. To close the summary, click on the same icon that opened it. When models are created for a job like this, it is generally built to a finished surface. That would be top of asphalt, concrete, or gravel, depending on the job and materials. The operator would have to offset the thickness of the material to get to subgrade. We can do this in a few different ways. Below the left light bar, you will see the up and down arrows. If we click on the down arrow, you will notice that the offset numbers change by 1/10 at a time. The upper number here is showing you how much cut or fill you have, and the lower is our offset. The cross-section view also has a new line going across it that represents our new grade. If we have a large offset or a number not divisible by 1/10, we manually enter the offset by clicking and holding on the light bar. You can manually type in the offset here. A negative number means that you want to go lower or cut more. Step is the amount of each vertical offset button will add or subtract when pushed. If the job has more than one vertical offset, for instance, one for subgrade and one for top or rock or finish course, you can save the current offset number by clicking and holding the preset, making it easier to change in the future. Guidance lines will provide us with station and offset from a selected line. This will work with any of the CAD lines that you bring in under the line work file. From the main screen views, click and hold on the line that you would like to get the stationing and offset from. A new menu will appear. Select the Use Guideline checkbox and select OK. We will now see stationing and offset while I navigate along this chosen line. Now that we know how to use grade metrics with a job that has already been loaded, I will show you how to create a job and describe the files needed to start. The top left icon is how we access the menu. The very first option is New Job. First, we name the job and click Next. The localization file is gathered by using a rover. The job or project will have known control points that are established by the surveyor in the early phases of the design process. Sometimes you will find the northing, easting, and elevation of the control on the plans, or you'll have to request them from the project owner or general. When you get the control information, you'll have to shoot each control point using a rover. All this does is equate a specific lat, long, and height to a known northing, easting, and elevation. Once complete, you save it to a thumb drive and bring it into Grade Metrics. We also have the capability to bring in a calibration file from Trimble Construction or export the point data needed from TalkOn, making it easier for customers with mixed fleets. The second file needed is line work. This is the lines you see in plan views and are obtained from the project engineer or model builder. We accept DXF or DWG. I now have the localization and line work file selected. When I select Next, it'll ask me for the third and final file, a surface file that contains the project's finished grade attributes elevated to the correct elevation to form a three-dimensional surface that Grade Metrics can read. These can be built using CAD data or line work file from the engineer and numerous different CAD package. Or nowadays, it is relatively inexpensive to get built by a model builder. We accept most common file types like DXF, DWG, XML, DTM, among others. Once you select the surface file, click Next and make sure the units are set correctly. Next, one more time to see the localization file in text format. If bringing in a Trimble cal file, you will see the calibrations residuals here, showing how accurate the localization will be. Once satisfied, finish the project. Again, the above process is used for projects that have been engineered and have a CAD file or set of plans. The second way to control cut or fill within Grade Metrics is field design. This is useful when the customer will not be on an engineered site or that the site will need a redesign done. We have included a few tools that will still allow the machine owner to use Grade Metrics in this case. You would not need to localize the site or have any of the files for this to work. All you need is RTK corrections from a base or VRS corrections from the internet. Setting a base on an unknown point and make it broadcast is easily done in Site Metrics. From the main screens, go to the menu and select Field Design. We have 4 different types of field designs that we can use. Notice that every type of field design can be named and is automatically saved for future use, making it easier to switch back and forth between saved field designs. Flat pad will create a pad at the same elevation on all sides of the machines forever. To use this, first drive the machine to a known grade or stake. If the stake has a cut or fill to the desired grade, we can fix that later in the vertical offset menu. Give the pad an appropriate name and select Record. And now finish. You will see that the color of the surface has changed to green, and now you have a flat pad. We can still see the job's design surface in red, but if I drive over the portion sticking above the new pad, it will still give me the cut or fill to the pad, and not the design surface, making it easier to use when doing redesigns in the field. If the stake you bench on at the beginning had a cut or fill, you can easily add it by clicking and holding on the light bar and typing it in. The second field design is hold slope. This is used in conjunction with guidance lines to allow a particular percentage off a line based off the position of the bucket and the guidance line selected. To select the guidance line, tap on the line you would like to use and check mark the Use Guideline box and press OK. Now, position the excavator with the desired bucket cross slope. The emulator does not allow me to angle the bucket, so I will only be able to show you using 0% crossfall. If I go back into field design and hold slope, I can press record. And now finish. You will see a new surface color holding that 0% crossfall at the guidance line's elevation. This would be useful for road slope redesigns or if a contractor needed a place to get rid of extra material. The third option in field design is sloped pad. This will do anything a dual plane laser can do. Useful for parking lots and tie-ins between 2 known areas. To start, position the machine on a known grade or stake facing the direction of the proposed main fall slope and press record. And then next. You would now drive the excavator in the direction of the main fall heading, and you can also place the bucket down to establish the main fall percent between the 2 points, or you can type in the percent manually. I cannot move the excavator in the emulator while in this menu, so I'll just type in the bearing, distance, and slope and select record. And next. Now it is asking me for a desired cross slope. I'll give it a positive 5% so we can see it when it's finished. Now, when I track ahead, you can see the existing surface fade because of the increased slope while moving forward, and we have that 5% crossfall. The last field design we have is ramp. It is very similar to sloped pad, but it will give you the option for a grade break or 2 sloped pads based off the line that you record. Think of a V-ditch or a crowned road. This is useful for creating roads, trenches for underground, and tie-ins between 2 known areas. Just like slope pad, I will start with a known grade, elevation, or stake, and start with the machine facing the proposed main fall direction and press record. And next. You would again drive in the direction of the main fall to establish the bearing, and either use the bucket to create the main fall slope or enter in manually, and press record. Since I cannot move the machine in this menu, I'll type in the bearing, distance, and slope and select next. Now, it is wanting me to build a cross-section template. Side of center is used to tell you what side of the center line I want to project my new lane. I will give it a 12-foot width with a -2% fall on the left. And now I will do the same on the right. You could also add additional lanes to the template if needed, giving the operator the ability to build a complex model with ease. Once satisfied with the template created, just push next and then finish. You can now see the crowned road that we have created. 2D is the final way grade metrics is used to give cut or fill inside the cab. It is used if the machine does not have access to RTK corrections from a base or internet corrections from a VRS network. The operator will use the bucket of the machine to reference where grade is. For instance, if the operator knows a particular part of ground is at grade or has a stake that has a known elevation or cut or fill, he can place the bucket down on that location and tell the system that is grade. Keep in mind, when using 2D, you will have to touch the same point with the bucket before and after you track the machine to compensate for the elevation change in the machine movement. We also offer an optional laser receiver to help maintain the machine's vertical position. When we go into the menu and grade 2D, you will see a list of icons on the right side. The very top icon will allow us to choose what type of 2D entity we would like to build. Every option will ask for a name and will also save the associated settings to that name so you can easily select them for later use. These are configured similarly to field design. For the sake of time, I will only briefly cover them. Flat pad will create a level pad at the same direction on all sides of the machines forever. Single slope pad will give you a pad with a single main fall percent rise or fall. Dual slope pad will give you a pad with a main fall percent and cross fall percent too. Trench is used to create a percent-based main fall baseline that, once established, will allow you to create node-based cross-section templates. This would be extremely useful for underground guys. Profile is similar to trench, but instead of creating templates used in cross-section, you will be creating them in the profile view. This would be useful if you were excavating a ditch with multiple grade breaks, and you had to excavate them from the side and not lengthwise. Once you've created a particular 2D entity, just press record and finish. You will now be in the main screen 2D view. I will lift the bucket up in the air so that it now shows that we have a cut. Let's just say this is where I'd want grade metrics to show me grade. To do this, I would bench or reference this new position using the second icon. All I have to do is press record and now finish. Now, grade metrics is showing me the grade where my bucket tip is located. If I was benching on a stake with a cut or fill, I would just have to use the vertical offset tab to add or subtract the number. If you have finished the cut in front of you and need to track the machine back, you would first have to place the bucket down on a known area that can be referenced after you track the machine so that any elevation change created while moving will be zeroed out. First, place the bucket down on an area that you can reach again after you have tracked the machine back, and select the traverse icon. Notice that the icon has changed and the traversing text in the upper left. This is telling us that it's safe to move. We would track the machine back and replace the bucket on the same spot and select the icon again. The surface will adjust to our new elevation and the icon will go back to its initial state. If you think your customer will be using the 2D functionality of grade metrics often, then I would suggest adding our optional laser receiver. This will make it easier and quicker to rebench after moving the machine. Instead of tracking vertical machine movement using the above method, the operator would simply strike the receiver with a laser every time they move. Inside the Topo submenu, the excavator has the capability to manually record single points and also record points based off predetermined distances or time automatically. You can also save any points recorded to a certain file. For example, you could have a file for utilities, existing topo, or manholes. You can also add a code description to the point by using our default selection or add your own. In the main view of Topo, you just have to choose to shoot a single shot for a manually recorded point, or you can start the auto topo using the established values in the setup menu. There is a second page to our menu that is used to change the radio channel or add login credentials for a VRS network. This is also where the install wizard is located. Equipment setup will guide you through the install process. First, name the machine and pick the units you are using to measure the machine. The next menu is asking for the model type of the GNSS receivers. For 10 ton and under 4 meter reach, you can use the VR500. For anything over that size, we would use the VR1000 so we get a larger baseline across the receivers. All of the location dimensions are automatically added after the 3D calibration is finished, so you do not have to measure these. The chassis is for scaling the image of the dozer in grade metrics. Slew offsets will automatically be populated after the 3D cal as well. Lengths are the first set of critical measurements needed. These should be within a few hundredths accuracy. Arctic boom is used for a second boom. Traditionally, we don't see many of these in North America. Laser tab is for measuring the placement of the optional laser receiver if used. The dog bone tab is also another set of critical measurements. Again, measure within a few hundredths. The bucket tab is used to measure any of the buckets the machine has. L3 will populate itself from the dog bone tab. The next menu is used to tell where the sensors are located and which way they're facing. On the excavator, we have a total of 4 sensors. They are located on the body, the boom, the stick, and the dog bone. If using a tilt bucket, you would add a 5th sensor. The sensors are shaped like an arrow, so it is easy to identify the facing. The writing on top of the sensor is used to tell the position. The final screen shows us the measurements we've inputted, verified that they are correct, and finished to save. The second step of the install process will be calibrating the sensors. First, park on a flat, level surface and line the machine up like showing on the image, with the tracks and machine body parallel to each other, and press calibrate. And next. Now the machine is flipped around. Use the compass arrow in the lower left corner. The point of the arrow should be in the green. I cannot move the machine in the emulator, so I'll just have to calibrate here. For the boom, we would use a string centered on both the boom and stick pins, held on using magnets, and using a string line level to get the boom pin and stick pin level with each other. Once completed, press calibrate. Notice there's a box in the lower left. You could use a laser or total station and add the height difference instead. The next sensor is the stick. Here we would drop a plumb bob down from the stick pin to the bucket pin. Once the two are centered and plumb, press calibrate. And next. For the dog bone, using a level, we get the dog bone pins level and press calibrate. And next, the bucket. We drop a plumb bob from the bucket pin and plumb it with the bucket tip and press calibrate. And finish to save. The final install process is the 3D calibration. The emulator doesn't properly allow me to show this step, so I can only describe it. The installer would align the machine in 90-degree segments, and the machine would record each position. Then, 5 points are recorded using the rover. These 5 points include secondary antenna position, center of the boom, center of the bucket, right bucket pin, and left bucket pin. These points are then brought into grade metrics, and the install process is complete.